Hey guys, so I'm learning DeepSeek. That is what I'm doing. And that is so cool. So let's see. Let's learn.
DeepSeek. So first we're going to look at the DeepSeek website where you can utilize it just like use ChatGPT. After that, we will download it using Olama and have an idea of its capabilities there. Then we'll use another tool called Studio LM, which will allow us to run the model locally, but have a bit of an agentic behavior. We're going to use an AIPC and also a modern graphics card, my RTX 4080. I'm going to show you some of the skills about troubleshooting with it, and we do run into issues with both machines, but it gives you kind of an idea of the capabilities of what we can use with DeepSeek and where it's not going to work. I also show you how to work with it with Hugging Face, with transformers, and to do local inference. So hopefully you're excited to learn that, but we will have a bit of a primer just before we jump in so we know what DeepSeek is, and I'll see you there in 1 second. Before we jump into DeepSeek, let's learn a little bit about it. So DeepSeek is a Chinese company that creates open-weight LLMs. V3, I remember what those are. They're somewhere in my GenAI Essentials course. The one we're going to be focusing on is mostly R1. We will look at V3 initially because that is what is utilized on DeepSeek. There's a paper where you can read all about how DeepSeek works, but DeepSeek-R1 is a model trained via large-scale reinforcement learning without supervised fine-tuning, and it demonstrates remarkable reasoning capabilities. R10 has problems like poor readability and language mixing, so R1 was trained further to mitigate those issues, and it can achieve performance remarkable reasoning capabilities. R10 has problems like poor readability and language mixing, so R1 was trained further to mitigate those issues, and it can achieve performance comparable to OpenAI O1, and they have a bunch of benchmarks across the board. Is performed 71 billion. Such a big deal is that it is speculated that it has a 95 to 97 reduction cost compared to OpenAI. That is the manufacturer's score because it really is dependent on your local hardware. We could run this in cloud, but it's not really worth it to do it. You really should be investing some money into local hardware and learning what you can in Android V series. And this came out in September 2024. It is a mobile chip, and the chip is special because it has an iGPU, so an integrated graphics unit. That's what the LM is going to use. It has an MPU, which is intended for smaller models. But that's what I'm going to run it on. The other one that we're going to run it on is my Precision 3680 Tower workstation, Optiplex. I just got this station. It's okay. It is a 14th generation iCore 9, and I have a GeForce RTX 4080. And so I ran this model on both of them. I would say that the dedicated graphics card did do better because they just generally do. But from a cost perspective, the Lake AI PC dev kit is cheaper. You cannot buy the one on the left-hand side because this is something that Intel sent me. There are equivalent kits out there. You just type in AI PC dev kit, Intel, AMD, all Qualcomm, they all make them. So I just prefer to use Intel hardware. But whichever one you want to utilize, even the Mac M4 would be in the same kind of line of these things that you could utilize. But I found that we could run about a 7 to 8 billion parameter model on either. But there were cases where when I used specific things and the models weren't optimized and I didn't tweak them, it would literally hang the computer and shut them down. Both of them, right? Both of them. So there is some finessing here and understanding how your hardware works. But probably if you want to run this stuff, you would probably want to have a computer on your network. So like my AIPC is on my network, or you might want to have a dedicated computer with multiple graphics cards to do it. But I kind of feel like if I really wanted decent performance, I probably need 2 AIPCs with distributing the LLM across them with something like Rayserve, or I need another graphics card with distributed because just having one of either or just feels a little bit too little. But you can run this stuff and you can get some interesting results. But we'll jump into that right now. Okay. So before we try to work with DeepSeek programmatically, let's go ahead and use DeepSeek.com's AI business computer. Now, I created this prompt document connected with my Google account. That is something that's really, really easy to do. And the use case that I like to test these things on is I created this prompt document for helping.
Omen King. Omen King. GitHub. Andrew Brown. Omen King. I teach people cloud. Okay, cool. Repositories. Gen AI. Free Gen AI.
Me learn Japanese. And so basically what the prompt document does is I tell it you're a Japanese language teacher and you're going to help me work through a translation. And so I have one where I did on Meta, Claude, and ChatGPT. So we're just going to take this one and try to apply it to DeepSeek. The one that's most advanced is the Claude one. And here you can click into here and you can see I have a role, I have a language, I have teaching instructions, we have agent flow, so it's handling state. We're giving it very specific instructions, we have examples. And so hopefully what I can do is give it these documents and it will act appropriately. So this is in my GitHub. It's completely open source or open to you to.
Nice, nice, nice. It seems a little different. Sentence constructor. Okay, yeah, this is ChatGPT. Is this example XML? Prompt. Japanese language teacher.
Access at Omen King Free Gen AI Bootcamp 2025 in the sentence constructor. Well, what I'm going to do is I'm in GitHub and I'm logged in, but if I press period, this will open this up in github.dev. And so now I can download those files and make it a little bit easier to work with them. So that's what I'm doing. I'm just opening this in github.dev and we'll get a VS Code like editor. So we'll just give it a moment here. And so the next thing I'm going to do here is just give it a moment. And I'm going to go into the Claude folder. Basically, these other ones, you could use these ones. These are just very simple prompts. But what I did is over time, I made it more advanced. And the Claude one is the one that we really want to test out. So I have these. And so I want this one here. This is a teaching test. That's fine. I have examples and I have consideration examples. Okay, so I'm just carefully reading this. I'm just trying to decide which ones I want. I actually want almost all of these. I'm just going to download the folder. So I'm going to go ahead and download this folder. I'm going to just download this to my desktop. Okay, and it doesn't like it unless it's in a folder. So I'm going to go ahead and just hit download again. I think I actually made a folder on my desktop called, nope, maybe not download, but we'll just make a new one called download. Okay, I'm going to go in here and select. We'll say view, save changes, and that's going to download those files to there. So if I go to my desktop here, I go to download, we now have the same files. Okay, so what I want to do next is I want to go back over to DeepSeek, and it appears that we can attach files. So it says text extraction only, upload docs or images. So it looks like we can upload multiple documents. So these are very small documents. And so I want to grab this one, this one, this one, this one, and this one. And I'm going to go ahead and drag it on in here. Okay. And actually I'm going to take out the prompt MD, and I'm actually just going to copy its contents in here because the prompt MD tells it to look at those other files. So we'll go ahead and copy this. Okay, we'll paste it in here. Hit enter, and then we'll see how it performs. Another thing we should check is its vision ability. We'll go here. So let's break down a sentence example for sentence structure. Looks really, really good. So next possible answers, try formatting the first clue. So I'm going to try to tell it to give me the answer. Just give me the answer. I want to see if I can subvert my instructions. Okay, and so it's giving me the answer, which it's not supposed to be doing. Did I tell you not to give me the answer in my prompt document? Let's see if it knows. My apologies for providing the answer clearly. So already it's failed on that, but I mean, it's still really powerful. And the consideration is like, even if it's not as capable as Claude or as ChatGPT, it's just the cost factor. But it really depends on what these models are doing. Because when you look at Meta AI, right? If you look at Meta AI, or you look at Mistral 7, these models, they're not necessarily working with a bunch of other models. And so there might be additional steps that Claude or ChatGPT is doing so that it doesn't, like, it makes sure that it actually reads your model. But so far, right, like I ran it on these ones as well, but here are equivalents of more simpler ones that don't do all those extra checks. So it's probably more comparable to compare it to like Mistral 7 or Llama in terms of its reasoning. But here you can see it already made a mistake, but we were able to correct it. But still, this is pretty good. So, I mean, that's fine. But let's go test its vision capabilities because I believe that this does have vision capabilities. So I'm going to go ahead and I'm looking for some kind of image. So I'm going to say Japanese text, right? I'm going to go to images here and we'll say Japanese menu. And Japanese, again, even if you don't care about it, it's a very good test language as it really has to work hard to try to figure it out. And so I'm trying to find a Japanese menu in Japanese. So what I'm going to do is say translate. Maybe we'll just go to like a Japanese website. So we'll say Japanese hotel. And so, or maybe you can go better. We'll say Japanese newspaper. That might be better. And so this is probably one. Mainichi, okay. And I want it actually in Japanese. So that's the struggle here today. So I'm looking for the Japanese version. I don't want it in English. Let's try this JapaneseTime.jp. I do not want it in English. I want it in Japanese. And so I'm just looking for that here. Just give me a second, okay? I went back to this first one in the top right corner. It says Japanese. And so I'll click this here. So now we have some Japanese text. Now, if this model was built by China, I would imagine that they probably really good Chinese characters and Japanese borrow Chinese characters. And so it should perform really well. So what I'm going to do is I'm going to go ahead and have no idea what this is about. We'll go ahead and grab this image here. And so now that is there. I'm going to go back over to DeepSeek. And I'm going to just start a new chat. I'm going to paste this image in. I'm going to say, can you transcribe the Japanese text in this image? This is what we want to find out. Can I do this? Because if we can do that, that makes it a very capable model. And transcribing means extract out the text. Now, I didn't tell it to produce the translation. It says this text discusses a scandal involving a former talent, et cetera, et cetera. Can you translate the text and break down the grammar? And so what we're trying to do is say break it down so we can see what it says. Formatting is not the best. Oh, here we go. Here, this is what we want. So just carefully looking at this. Possessive, advancement, to ask a question, voices also. Yeah, it looks like it's doing what it's supposed to be doing. So yeah, it can do vision. So that's a really big deal. But it is V3 and that makes sense. But this is DeepSeek, this one. But the question will be, what can we actually run locally? As there has been claims that this thing does not require series GPUs. And I have the hardware to test that out on. So we'll do that in the next video. But this was just showing you how to use the AI power assistant if you didn't know where it was, okay? All right, so in this video, we're going to start learning how to download the model locally because imagine if DeepSeek is not available one day for whatever reason. Again, it's supposed to run really well on computers that do not have expensive GPUs. And so that's what we're going to find out here. The computer that I'm on right now, I'm actually remoted. Like I'm connected on my network to my Intel developer kit. And this thing, you probably bought it brand new. It's between $500 to $1,000. But the fact is that this thing is a mobile chip. I called it Lunar Lake, but it's actually called the Core Ultra 200V series mobile processors. And this is the kind of processor that you could imagine will be in your phone in the next year or two. But what's so special about these new types of chips is that when you think of having a chip, you just think of CPUs and then you hear about GPUs being an extra graphics card. But these things have a built-in graphics card called an iGPU, an integrated graphics card. It has an MPU, a neural processing unit, and just a bunch of other capabilities. So basically, they've crammed a bunch of stuff onto a single chip, and it's supposed to allow you to be able to run ML models and be able to download them. So this is something that you might want to invest in. You could probably do this on a Mac.
Here's how I run DeepSeek-R1 locally on my MacBook Air. The machine that I use is M1 MacBook Air, which I've been using for the last 4 years. Now since the new models are out, I wanted to give it a try. To run the LLMs locally, I agree. But before I chose the models, what I did was I chose an AI platform to run it entirely offline. And the platform that I chose was OpenWebUI, and I used Docker to run it locally on my machine. So now the application was up and running. Now I needed to pull the models for it to work. You can select the models from the Ollama library. I wanted to run the 1.5 billion parameter DeepSeek-R1, so I chose the model name of that and downloaded the. Once that was set up, I can use it completely as my own personal ChatGPT. It was a bit slow for me because of my system specification. Do try it out.
Mac M4 as well, or some other things, but this is just the hardware that I have. and I do recommend it. But anyway, one of the easiest ways that we can work with the model is by using Olama. So Olama is something I already have installed. You just download and install it. And once it's installed, it usually appears over here, and mine is over here. Okay, but the way Olama works is that you have to do everything via the terminal. So I'm on Windows 11 here. I'm going to open up terminal. If you're on a Mac, same process. You open up terminal. And now that I'm in here, I can type the word Olama. Okay, so Olama is here. And if it's running, it shows a little Olama somewhere on your computer. So what I want to do is go over to here, and you can see it's showing us R1. Okay, but notice here, there's a drop down. Okay, and we have 1.5 billion, 7 billion, 8 billion, 14 billion, 32 billion, 70 billion, 671 billion. So when they're talking about DeepSeek-R1 being as good as ChatGPT's, they're usually comparing the top one, the 671 billion parameter one, which is 404 gigabytes. I don't even have enough room to download this on my computer. And so you have to understand that this would require you to have actual GPUs or more complex setups. I've seen somebody, there's a video that circulates around that somebody bought a bunch of Mac minis and stacked them. Let me see if I can find that for you quickly. All right, so I found the video, and here is the person that is running. They have 1, 2, 3, 4, 5, 6, 7 Mac minis, and it says they're running DeepSeek-R1, and you can see that it says M4 Mac minis, and it says total unified memory 496 gigabytes, right? So that's a lot of memory, first of all, and it is kind of using GPUs because these M4 chips are just like the Lunar Lake chip that I have in that they have integrated graphics units, they have MPU. Now, you only need really one of these, of whether it is like the Intel Lunar Lake or the Mac M4 or whatever Ryzen that Ray serve. You'll notice, like, look at the type speed. It is not, it's not fast. It's like clunk, 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 clunk. So some of these other models, right? But you do need to invest in something. We're not running this one. There's no way we're able to run this one. But we can probably run easily the 7 billion parameter one. I think that one is doable. I would definitely do the 1.5 billion one. And so this is really what we're targeting, right? It's probably the 7 billion parameter model. So to download this, all I have to do is copy this command here. I already have Olama installed. And what it's going to do is it's going to download the model for me. So it's now pulling it from probably from Hugging Face. Okay, so we go to Hugging Face and we say DeepSeek-R1. What it's doing is it's grabbing it from here. It's grabbing it from Hugging Face, and it's probably this one. There are some variants under here, which I'm not 100% certain here, but you can see there's distilments of other models underneath, which is kind of interesting. But this is probably the one that is being downloaded right now, at least I think it is. And normally what you're looking for here is we have these safe transfer files, and we have a bunch of them. So yeah, I'm not exactly sure. We'll figure that out here in a little bit, but the point is that we are downloading it right now. We go back over to here. And you can see it's almost downloaded, so it doesn't take that long. But you can see they're a little bit large, but I should have enough RAM on this computer. I'm not sure how much this comes with. Just give me a moment. So what I did is I just opened up system information, and then down below here, it's saying I have 32 gigabytes of RAM. So the RAM matters because you have to have enough RAM to hold this stuff in memory. And also, if the model's large, you have to be able to download it. And then you also need the GPUs for it. You can see this is almost done. So I'm just going to pause here until it's 100% done. And it should, once it's done, it should automatically just start working. Now it is ready. So it didn't take that long, just a few minutes. And we'll just say, hello, how are you? And that's pretty decent. So that's going at an okay pace. Could I download a more intensive one? That is the question that we have here. Because we're at the 7 billion. We could have done the 8 billion. Why did I do 7 when I could have done 8? The question is, like, where does it start kind of chugging? It might be at the 14 billion parameter model. Just test this again. So hello, let's try this again. But you can see that we're getting pretty decent results. The thing is, even if you had a smaller model, through fine tuning, if we can fine tune this model, we can get better performance for very specific tasks if that's what we want to do. But this one seems okay. So I would actually kind of be curious to go ahead and launch it. I can hear the computer spinning up from here, the Lunar Lake dev kit. But I'm going to go ahead and just type in buy. And I'm going to just go here. I want to delete that one. So I'm going to say remove, and that was DeepSeek-R1. First, let's list the model here, because we want to be cautious of the space that we have on here. And this model's great. I just want to have more. I just want to run the 8 billion parameter one or something larger. So this is ultra close partner. We're not sure how long to get this model, but obviously there are different ones like the DeepSeek-R1 or LM Studio. We'll do in the next video, and that will give you more of a AI-powered assistant experience. So not necessarily working with it programmatically, but closer to the end result that we want. I'm not going to delete the model just yet here, but if you want to, so see you in the next one. All right, so here we're at Studio LM or LM Studio. I've actually never used this product before. I usually use WebUI, which will hook up to Olama, but I've heard really good things about this one, and so I figured we'll just go open it up and let's see if we can get a very similar experience to having like a ChatGPT experience. And so here they have downloads for Mac, the Metal series, which are the latest ones.
Here's how I run Deep. Was an AI platform to run it entirely offline, and the platform that I chose was OpenWebUI, and I
Open Web UI.
Ones, Windows and Linux. So you can see here that they're suggesting that you want to have one of these new AI PC chips, as that is usually the case. If you have GPUs, then you can probably use GPUs. I actually do have really good GPUs. I have a 4080 RTX here, but I want to show you what you can utilize locally. So what we'll do is just wait for this to download. Okay, now let's go ahead and install this. But I'm really curious on how we are going to plug this into, like how are we going to download the model, right? Does it plug into Olama? Does it download the model separately? That's what we're going to find out here just shortly when it's done installing. So we'll just wait a moment here, okay? All right, so now we have completing the ML Studio setup. So LM Studio has been installed on your computer. Click Finish and Setup. So go ahead and hit Finish. Okay, so this will just open up here. Give it a moment to open. I think in the last video we stopped Olama, so even if it's not there, we might want to, I'm just going to close it out here. Again, it might require Olama. We'll find out here in a moment. So get your first LM. So here it says Llama 3.2. That's not what we want. So we're going to go down below here. It says enable local LM service on login. So it sounds like what we need to do is we need to log in here and make an account. I don't see a login. I don't. So
Someone. Hi. Okay. Hi. I just learned. I just learned C++ basic. And STL also, I'm unable to solve any lead code problems, even easy ones, man. Can you suggest a way to solve lead code problems? Watch videos. So, like, if you can't solve them, it's okay not to solve them. It's like you don't know the basic of C++. I am really telling you, you don't, you just know there are STLs, you know there are C++, but if you had done C++ in 11th, 12th, in 11th, 12th, they teach you how to draw patterns in C++. That opens up your brain to a little more of logic. And that's where you learn to solve a lot of problems. So just watch people do it. So if you can't like if you go with an easy problem, this is the exact roadmap that I would give you. Go with an easy problem, try for 20 minutes. If you can solve it, that's the best option. But if you cannot, then just move on, look at the answer, and that's okay. You don't need to feel anything about that. Stay logical about this. Like that, there's no issue that you don't know anything because it has been like a few months. I don't know how YouTube creation works and everything works, but I'm figuring it out. I'm much better than the last few months that I was doing it. And I'm much better the last time I was reading JavaScript documentations when I was reading JavaScript documentation. It has been a long journey. I've had friends who have cracked this out and are earning like $3,000, $4,000 uh like in different fields. But I chose this field and I'm working on it. I get it, not get it, that is not an issue. The issue is doing and just do what you have a goal, and if it works out, it works out. Does not work out, bro, it's not necessary to be in tech. Open something different up. If you are knowledgeable enough to study engineering, you can easily open another business or something where you can do better. So it's not necessary to get a tech job. Don't stress on it. Just do it, and if it works out, it works out. Does not work out, it does not. Pressure mat lo, bro.
So we'll go back over to here, and they have this onboarding step. So I'm going to go and we'll a specific one. And so this is what I'm trying to figure out from the bottom of the corner. We have some options here. And I know it's hard to read. I apologize. There's no way I can make the font larger, unfortunately. But they have the lmstudio.ai. So we'll go over to here. We go to the model catalog, and we're looking for DeepSeek. We have DeepSeek Math 7 billion, which is fine. But I just want the normal DeepSeek model. We have DeepSeek Coder version 2, so that'd be cool if we wanted to do some coding. We have distilled ones. We have R1 distilled, so we have Llama 8 billion distilled and Quen 7 billion. So I would think we probably want the Llama 8 billion distilled. Okay. So it says use an LM Studio, so I'm going to go ahead and click it, and we'll click open. Okay, now it's going to download the model, so 4.9 gigabytes. We'll go ahead and do that. So that model is now downloading. So we'll wait for that to finish. Okay, so it looks like we don't need a llama at all. This is like all-inclusive one thing to go. So I do want to point out, notice that it has a gguf file, so that makes me think that it is using like whatever llama index can use. I think it's called llama index, that this is what's compatible. Same thing with ollama, so they might be sharing the same stuff because they're both using gguf files. This is still downloading, but while I'm here, I might as well just talk about what distilled model is. So you'll notice that it's saying like R1 distilled llama 8 or Quen 7 billion parameter. So distillation is where you are taking a larger model's knowledge and you're doing knowledge transfer to a smaller model, so it runs more efficiently, but it has the same capabilities of it. The process is complicated. I explained it in my GenAI Essentials course, which this part of this crash course will probably get rolled into later on. But basically, it's a technique to transfer that knowledge. There's a lot of ways to do it, so I can't summarize it here. But that's why you're seeing distilled versions of those things. So basically, they figured out a way to take the knowledge. Maybe they're querying directly. That's probably what they're doing. Is like they have a bunch of evaluations, like queries that they hit with what do you call it, Llama or these other models, and then they look at the result, and then when they get their smaller model to do the same thing, then it performs just as well. So the model is done. We're gonna go ahead and load the model. And so now I'm just gonna get my head a little bit out of the way because I'm kind of in the way here. And so now we have an experience that's more like what we expect it to be. And on the top here, there's a way that I can definitely bring the font up here. I'm not sure if there is a dark mode. The light mode's okay, but a dark mode would be nicer. But there's a lot of options around here. So just open settings in the bottom right corner. And here we do have some themes. There we go. That's a little bit easier. And I do apologize for the small fonts. There's not much I can do about it. I even told it to go larger. This is one way we can do it. So let's see if we can interact with this. So we'll say, can you, I am learning Japanese. Can you act as my Japanese teacher? Let's see how it does. Now this is R1. This does not mean that it has vision capabilities, as I believe that is a different model. And I'm hearing my computer spinning up in the background, but here you can see that it's thinking. Okay, so I'm trying to learn Japanese and I came across the problem where I have to translate I'm eating sushi into Japanese. First, I know that in Japanese the order subject can be this. So it's really interesting. It's going through a thought process. So normally when you use something like web UI, it's literally using the model directly, almost like you're using it as a playground. But this one actually has reasoning built in, which is really interesting. I didn't know that it had that. So there literally is agent thinking capability. This is not specific to OpenSeek. I think if we run any model, it would do this. And so it's showing us the reasoning that it's doing here as it's working through this. So we're going to let it think and wait till it finishes, but it's really cool to see its reasoning, where normally you wouldn't see this, right? So you know when ChatGPT says it's thinking, this is the stuff that it actually is doing in the background that it doesn't fully tell you. But we'll let it work here and we'll be back in just a moment, okay? All right, so it looks like I lost my connection. This sometimes happens because when you're running a computational task, it can halt all the resources on your machine. So this model is a bit smaller, but I was still running OLAM in the background. So what I'm going to do is I'm going to go my Intel machine. I can see it rebooting in the background here. I'm going to give it a moment to reboot here. I'm going to reconnect. I'm going to make sure OLAM is not running, and then we'll try that again. Okay, so we'll be back in just a moment. You know what it was? The computer decided to do Windows updates. So it didn't crash, but this can happen when you're working with LLMs that it can exhaust all the resources. So I'm going to wait till the update is done. I'll get my screen back up here in just a moment, okay? All right, so I'm reconnected to my machine. I do actually have some tools here that probably tell me my use. Let me just open them up and see if anyone will actually tell me where my memory usage is. Yeah, I wouldn't call that very useful. Maybe there's some kind of tool I can download. So monitor memory usage. Well, I guess Activity Monitor can just do it, right? Or what's it called? Let's see if I can open that up here. Try to remember the hotkey for it. There we go. And we go to Task Manager. And so maybe I just have Task Manager open here. We can kind of keep track of our memory here. Oh, you know an idea. This computer just restarted. Go over to here. Can you show me the sentence? Can you show me Japanese using Japanese characters? The toppings right now. Flash attention would be really good. So decrease memory usage generation time on some models. That is where a model is trained on flash attention, which we don't have here right now. But I'm going to go ahead. I'm going to load the llama distilled model. And we're going to go ahead and ask if it can do this for us because that would make it a little bit more useful. Okay, so I'm going to go ahead and run that. And we'll be back here in just a moment. And we'll see the results. All right, we are back, and we can take a look at the results here. Let's give it a moment. I'm going to scroll up. And you know what's really interesting is that it is working. Every time I do this, it does work, but the computer restarts. And I think the reason why is that it's exhausting all possible resources. Now, the size of the model is not large. It's whatever it is, the 8 billion parameter one. At least I think that's what we're running here. It's a bit hard because it says 8 billion distilled, and so we'd have to take a closer look at it. It says 8 billion, so it's 8 billion parameter. But the thing is, it's the reasoning that's happening behind the scenes. And so I think for that, it's exhausting, whereas when we're using llama, it's less of an issue. And I think it might just be that LM Studio, the way the agent works, might not have ways of, or at least I don't know how to configure it to make sure that it doesn't destroy stuff when it runs out here. Because you'll notice here that we can set the context length. So maybe if I reduce that, keep model in memory, so reserve system memory for the model, even when off of the GPU performance requires more RAM. So here, we might toggle this off and get better production. But right now, when I run it, it is restarting. But the thing is, it is working. So you can see here, it thought for 21 seconds. It says, of course, I'd like to help you. And so here's some examples. And it's producing pretty good code, or like output, I should say. But anyway, what we've done here is we've just changed a few options. So I'm saying don't keep it in memory, okay? Because that might be an issue. And we'll bring the context window down. And it says CPU thread to allocate. That seems fine to me. Again, I'm not sure about any of these other options. We're going to reload this model. Okay, so we're downloading with those options. I want to try one more time. If my computer restarts, it's not a big deal. But again, it might be just LM Studio that's causing us these issues here. And so I'm just going to click into this one. I think it's set up those settings. We'll go ahead and just say, okay, so I'm going to say, like, how do I say in Japanese, where is the movie theater? Okay, it doesn't matter if you know Japanese, it's just we're trying to tax it with something hard. And so here it's running again, and it's going to start thinking. We'll give it a moment here. And as it's doing that, I'm going to open up Task Manager. And we'll give it a moment. I noticed that it has my, did it restart again? Yeah, it did. So, yeah. This is just experience. Again, it has nothing to do with the Intel machine. It's just, this is what happens when your resources get exhausted. And so it's going to restart again. But this is the best I can demonstrate here. It's like, that was more cost effective than buying a completely new computer outright. Those two were smaller mini PCs. But I'll be back here in just a moment, okay? So I'm going to get this installed on my main machine. My main machine, like as I'm recording here, it's using my GPU, so it's going to have to share it. So I'm just going to, and I'm on my main, change it to dark mode here. So our eyes are a little bit low to way over. That's now going to download this locally. Okay, so because I feel like it's going to cause this computer to restart, but because it's offloading to the GPUs, I'm hoping that'll be less of an issue. But here you can see it's loading the model into memory.
Open web UI. What is this? Open web UI is extensive. I want to know. We'll have to learn about Open Web UI after this.
Okay, and we really should look at our options that we have here. It doesn't make it very easy to select them.
Let's try not that. Let's try to get this.
but oh, here it is right here. Okay, so we have some options here, and this one actually is offloading the GPU. So you see it has GPU offload. I'm almost wondering if I should have set GPU offload on the AI PC because it technically has iGPUs, and maybe that's where we're running into issues, whereas when we were using old Llama, maybe it was already utilizing the GPUs, I don't know. But anyway, what I want to do is go ahead and ask the same thing. So I'm going to say, can you teach me Japanese for JLPT N5 level? So go ahead and do that. We'll hit enter. And again, I love how it shows us the thinking that it does here. I'm assuming that it's using our RTX 480 that I have on this computer. And this is going pretty decently fast here. It's not causing my computer to cry. This is very good. This is actually reasonably good. And so yeah, it's performing really well. So the question is, you know, again, I'd like to go try the developer kit again and see if because I remember the GPUs were not offloading, right? So maybe it didn't detect the iGPUs, but this thing is going pretty darn quick here, and so that was really, really good. And so it's giving me a bunch of stuff. It's like, okay, but give me example sentences in Japanese. Okay, so that's what I want. We'll give it a moment. Yep, and that looks good. So it is producing really good stuff. This model, again, is just the Llama 8 billion parameter. I'm going to eject this model. Let's go back over to here into the studio over here. And I want to go to the model catalog because there are other DeepSeek models. So we go and take a look at DeepSeek. We have Coder version 2, so the younger sibling of GPT-4, DeepSeek Coder version 2 model. But that sounds like DeepSeek 2, right? So I'm not sure if that's really the latest one because we only want to focus on R1. And so, yeah, I don't think those other ones we really care about. We only care about R1 models. But you can see we're getting really good performance. So the question is, like, what's the compute or the TOPS difference between these two? And maybe we can ask this over to the model ourselves. But I'm going to start a new conversation here. And I'm going to say, how many TOPS, or the TOPS, does, I think it's called TOPS, TOPS does RTX 4080 have? Okay, we'll see if we can do it. Just select this model here. And yeah, we'll load the model. And we'll run that there. We'll give it a moment. And while that's thinking, I mean, obviously we just use Google for this. We don't really need to do that. But I want to do a comparison to see like how many TOPS they have. So let that run in the background. I'm also just going to search and find out very quickly. Oh, here it goes. Does not have a specified number of tensor as officially NVIDIA. The company focuses on metrics like CUDAs, cores, and memory bandwidth. But this would be speculative. Okay, but then how do I compare TOPS for let's say Lunar Lake versus RTX 4080? And I know like there's lots of ways to do it, but it's like if I can't compare, how do I do it? And while that's trying to figure it out, I'm going to go over to Perplexity, and maybe we can get exact examples. I'm trying to understand like how much does my discrete GPU do compared to that one that's internal. So let's say Lunar Lake versus RTX 4080 for TOPS performance. And we'll see what we get. So Lunar Lake has 120 TOPS, and however much gaming rather than AI workloads, so NVIDIA doesn't typically advertise their TOPS, maintaining 60 FPS. Okay, but then, okay, but what could it be? Like, how many TOPS could it be for the RTX 4080? Kind of makes it hard because like we don't know how many TOPS it is. We don't know what kind of expectation we should have with it. Okay, fair enough. So yeah, so we can't really compare. It's like apples to oranges, I guess, and it's just not going to give us the result here. But here, it is going through comparison. So if you run ML GPUs like a model with ResNet, you directly compare the TOPS with the new architecture. And so that's basically the only way to do it. So we can't. It's apples to oranges. I want to go and attempt to try to run this one more time on the Lunar Lake. And I want to see if I can set the GPUs. But if we can't set the GPUs, then I think it's going to always have that issue specifically with this. But we will use the Lunar Lake for using with Hugging Face and other things like that. So we'll be back in just a moment, okay? All right, so I'm back, and I just did a little bit of exploration on my other computer there because I want to understand, like, okay, I have this AI PC. It's very easy to run this here on my RTX 4080, but when I run it on the Lunar Lake, it is shutting down. And I think I understand why. And so this is, I think, is really important when you are working local machines. You have to have a bit better understanding of the hardware. So I'm just going to RDP back into this machine here. Just give me just a moment. Okay, I have it running again. And it probably will crash again, but at least I know why. So there's a program called CoreTemp, and what CoreTemp does is it allows you to monitor this is for Windows. For Mac, I don't know what you use. You probably just Utility Manager. But here, you know, I can see that none of these CPUs are being overloaded. But this is just showing us the CPUs. If we open up Task Manager here, okay, and now the computer is running perfectly fine. It's not even spinning its fans. But on the left-hand side here, we can see we have CPUs, MPUs, and GPUs. Now, MPUs are the things that we want to use because MPUs, like an MPU, is specifically designed to run models. However, a lot of the frameworks, like PyTorch and TensorFlow, they're optimized on CUDA originally because of the underlying framework. And so normally you have to go through an optimization or conversion format. I don't know at this time if there is a conversion format for Intel hardware because DeepSeek is so new, but I would imagine that is something the Intel team is probably working on. And this is not just specific with, right? And so what we can do is just kind of, if I drop it down here and we click into this, right, we have our options. Before we didn't have any GPUs, but we can go here, we can say use all the GPUs. I don't know how much it can offload. The point is that if it exhausts the GPU, because it's all the thing I will do is I will go type in something like, sure. And now we can see the usual, before not any complaints right now. I'd have to update it and it's low or whatever, percent here, not to load memory. My old graphics card. And the Intel Lunar spot, I'm just really expensive. We'll just move on to graphics card. Let's take a look at how we can download the model from Hugging Face and then work with it programmatically. Is that's going to give you the most flexibility with these models. Of course, if you just want to consume them, these models, until they have optimizers for it. So we're talking about Intel again. You have this kit called OpenVINO, and OpenVINO is an optimization framework. And if we go down, I think they have like a bunch of examples here. We'll go back for a moment. Yeah, quick start examples, maybe over here. And maybe not over here, but we go back to the notebooks and we scroll on down. Yeah, they have this page here. And so in this thing, they will have different LLMs that are optimized specifically so that you can maybe leverage the MPUs or make it run better on CPUs. But until that's out there, we're stuck on the GPUs and we're not going to get the best performance that we can. So maybe in a month or so, I can revisit that and one. And so you can see there is a collection of models. And in here, we click into it. We have R1, R10, which I don't know what that is. Let's go take a look here. It probably explains it somewhere. We have R1 distilled 70 billion parameter, Qwen 32 billion parameter, Qwen 14. distilled versions, which gives him 1 billion. Okay, so this one literally is the big one. This is the really, really big one. And so that would be a little bit too hard for us to run on this machine. We can't run 671 billion parameters. You saw the person stacking all those Apple M4s. Like, yeah, I have an RTX 4080, but I need a bunch of those to do it. Down below, we have the distilled models. And so this is probably what we were using when we were using Olama if we wanted to go ahead and do that there. So this is probably where I would focus my attention on is these distilled models. When we're using Hugging Face, it will show us how we can deploy the models up here. And notice over here, we have BLLM. I covered this in my Gen AI Essentials course, I believe, but there are different types of ways we can serve models. Just as web servers have servers to serve them, like software underneath. So do these ML models, these machine learning models. And BLLM is one that you want to pay attention to because it can work with the Ray framework. And Ray is important because, say Ray, I'll just say ML here. But this framework specifically has a product within it called RayServe. It's not showing me the graphic here, but RayServe allows you to take VLM and distribute it across compute. So when we saw that video of that, again, those Mac M4s being stacked on top of each other, that was probably using RayServe with VLM to scale it up. And so if you were to run this, you might. But there's also V3, which has been very popular as well. And that actually is what we were using when we went to the DeepSeek website. But if we go over to here and we go into DeepSeek-R1, I think this one's a mixture of experts model. And this would be a really interesting one to deploy as well. But it's also 671 billion parameter model. So it's another one that we can't deploy locally, right? But if we did, we could have like vision tasks and all these other things that maybe it could do. So we're going to really just have to stick with the R1, and it's going to be with one of these distributions. I'm going to go with the Llama 8 billion parameter. I don't know why we don't see the other ones there, but 8 billion is something we know that we can reliably run, whether it's on the Lunar Lake or if it's on the RTX 4080. And so I'm going to go over here to the right-hand side. We have transformers and VLMs. Transformers is probably the easiest way to run it. And so we can see that we have some code here. So I'm going to get set up here. I'm going to just open up VS Code. And I already have a repo. I'm going to put this in my Gen AI Essentials course because I figured if we're going to do it, we might as well put it in there. And so I'm going to go and open that folder here. And I need to go up a directory. I might not even have this cloned. So I'm going to just go and grab this directory really quickly here. So just cd back. And I do not. So I'm going to go over to GitHub. This repo is completely open. So if you want to do the same thing, you can do this as well. We're going to say Gen AI Essentials. Okay. And I'm going to go ahead and just copy this and download it here. So give it a clone, get clone. And I'm going to go ahead and open this up. I'm going to open this with Windsurf for fun because I really like Windsurf. I've been using that quite a bit. If I have it installed here, should, yeah, I do. I have a paid version of Windsurf, so I have full access to it. If you don't, you can just copy and paste the code. But I'm trying to save myself some time here. So I'm going to open this up. I'm going to go into the Gen AI Essentials. I'm going to make a new folder in here. I'm going to call this one DeepSeek. And I want to go inside of this one and call it R1 Transformers. Because we're going to just use the Transformers library to do this. I'm going to select that folder. We're going to say yes. I'm going to make a new file here. And I probably want to make this an Iron Python file. I'm not sure if I'm set up for that, but we'll give it a go. So what we'll do is we'll type in basic.ironpython YNB, which is for Jupyter Notebooks. And you'd have to already have Jupyter installed. If you don't know, in my Gen AI Essentials, I show you how to set this stuff up, so you can learn it that way if you want. I'm going to go over to WSL here, and yeah, I'll install that extension there if it wants to install there. And I'm going to see if I have content installed. I should have it installed. There it is. We have a base. So anytime that you are setting up one of these environments, you should really make a new one because that way you'll run into less conflicts. And so I need to set up a new environment. I can't remember the instructions, but I'm pretty certain I show that somewhere here, local developments in this folder. And so if I go to Conda and I go into setup, I think I explained it here. So for Linux, that's what I'm using right now with Windows Subsystem Linux 2, is I would need to, it's already installed. So I want to create a new environment. So I probably want to use Python 3.10.0 if it's the future. You might want to use 3.12. But this version seems to give me the least amount of problems. So I want this command, but I want to change it a little bit. I don't want it to be hello. I want to call this DeepSeek. So we'll go back over to here. We're going to paste it into here. And so now we are setting up Python 3.10, and it's going to install some stuff. Okay, so now we are good. I need to activate that. So I'm going to say conda activate DeepSeek. And so now we're using DeepSeek. I can go back here on the left-hand side. And what I want to do is I want to get some code set up here. So we go back over to here into the 8 billion distilled model. We go to transformers. We have some code. And if it doesn't work, that's totally fine. We will tweak it from there. I also have example code lying around. So for whatever reason, this doesn't work. Sorry, just pause there for a second. If it doesn't work, we can grab from my code base here because I don't always remember how to do this stuff. Even though I've done a lot of this, I don't remember half the stuff that I do. So we're going to go ahead here and cut this up and put this up here. But we're going to need, I'm not sure how well, Windsurf works within Iron Python. I actually never did that before. So it's asking us to start something. We need to select a kernel. And I'm going to say, oh, it's not seeing the kernels that I want. But you know one thing I don't think we did is I don't think we installed Iron Python. So there's an extra step that we're supposed to do to get kernel installed. The following packages are not available for installation. Oh, type in C, not hyphen F, right? Give it a second. It was code. Then I got Essentials. I'm just going to say open. I'm not sure that I made one Transformers folder. I'm looking for the DeepSeek folder. There it is. We'll click into it. And I did not save any code, which is totally fine. It's not like it's too far away to get this code again. And so I'm going to go back over to here, and we're going to grab this code. Okay, I'm going to paste it in. But I'm going to just try from the most bare bones thing. It's going to tell me Transformers isn't installed, and that's totally fine. And I'm just trying to, there we go. And so I'm going to go to Python environments. I know that we do this before, so we might as well go leverage code and see what we did here before. Here we have Hugging Face Basic. And so here, yeah, we do an install with Transformers. So that's all we really need. There's PyTop. Okay, so we'll give that a moment to install. It shouldn't take too long. We might also need to install PyTorch or TensorFlow or both. That's very common when you are working with open source models, is that they may be in one format or another and need to be converted over. Sometimes you don't need to do it all, but we'll see. So now it's saying to restart. So we'll just do a restart here. We should only have to do that once. And so I'm going to go ahead here and now include it. So now we have less of an issue. Here it's showing us this model. So basically this will download it specifically from Hugging Face. So if we grab this address here and we go back over to wherever, I had one open here just a moment ago. And it should match this address, right? So if I was to just delete this out here, put it in here, it's the same address, right? So that's how it knows what model it's grabbing. But we'll go back over to here. And it doesn't look like we need our Hugging Face API, but we'll find out here in just a moment. So it should download it. We'll get a message here. We'll load transformers. We'll have tokenizers. Then we'll have the model. The messages here is being passed into here. It says copy local model directory directly. Okay. So I think here is like we just have two different ones. We have one that's using the pre-trained one. Yes, there's two ways that we can do it. And I think we cover this when you use a direct model or a pipeline. And so let's go ahead and see if we can just use the pipeline. Okay. If I don't remember how to do this, we'll probably go over here and take a look. I don't remember everything that I do, but yeah, this is the one we just had open here just a moment. I'm just going to run this. This is safe TensorFlow because I saw that. And because some sure, and 2.0 and PyTorch to run a transform to use 2.0. No, but so I'm gonna, really get us very far. It was supposed to be a really good one. The other thing that we could do is go take is still installed, and we can just leave it there as a separate line. We'll just say pip install TensorFlow. It would be pretty good. Is it utilizing my GPUs? I would think so. Very key. Looking for the Hugging Face token webcam utility here. But the thing that we saw was that taking a significant machine, but there's a tool here called NVIDIA SMI, and it will actually show us the usage here and GPU, which is a format here in this, at least not in that format. Okay, so you can see where the challenges are coming here. So we go over to our files and we take a look here. We can see we have a bunch of safe sensors. That's not going to really help us that much. We got to go back into DeepSeek here, and we'll look into the ones that they have here. 8 billion. There is Quen 7 billion, which is a bit smaller. There's also the 1.5 billion one. That's not going to be useful for us, but you know what? I'm kind of exhausting my resources here, so we can run if we knew that. All right, I'm back, and I also just went ahead and I ran it, and getting this one and the LGP here, for me, really does work. I was able to get BLM, what we learned as we were working through it.
Okay,
One thing I realized is that in order to run these models, you really do need optimized models. And
I think I will next. I would like to learn how does because I have a project, so I'm learning this. I want to learn how does these AI chatbots work, and that's what I will be looking at next. Oh, so I'll be back. I'll be back with another. I think that's enough for DeepSeek because we can run DeepSeek using
when we were using
Olama.
Olama, if you remember, it had the GG
Uh,
UF extension. That's that file format that is more optimized to run on CPUs. I know that with Llama Index from my Gen AI Essentials course when I did that exploration. So optimized models are going to make these things a lot more accessible. When we were using Notebook LM or whatever it was called, we saw that it wasn't Notebook LM, it was LM Studio. Notebook LM is a Google product, but LM Studio, it was adding an extra thought process, and so more things were happening there. It was exhausting the machine. Even on my main machine where I have an RTX 4080, which was really good, you could see that it ran well. But then when we were trying to work with it directly, where we didn't have an optimized model that we were downloading, my computer was restarting. So add to this, where I was trying, it was really, really tricky. And even with an RTX 4080 and with my not really designed to use LMs, I was saying earlier, maybe it was a way to optimize.
yeah, these machines are not designed to use LLMs, but we have to. But I'll be back in just 5 minutes with a video where I explore making chatbots using AI.